Good morning to all of you. Welcome to the online classes of Good Samaritan School for Mathematics, class 10th. I am Chandan Kumar. I am going to teach you today the topic related to coordinate geometry. So far we have discussed about the distance formula and also some of the basic concepts related to the coordinate geometry which we had already studied in class 9th. Today I am going to solve some of the questions related to distance formula which will help you to understand the concept more clearly, and then you will all be able to solve the problem easily. Now we'll see one question based on the concept of distance formula. The question is, find a point on the x-axis which is equidistant from 2, -5 and -2, 9. So we have a point which is on the x-axis and which is equidistant from the two given points. And we all know that if the point is on the x-axis, the y coordinate is 0, and if the point is on the y-axis, the x coordinate is 0. So let the point on the x-axis be x, 0. Since it is on the x-axis, the coordinate y is 0. The value of the ordinate is 0. Now this is the diagram. P is the point and A and B are the 2 points from which they are equidistant from P. So PA is equal to PB. We all know that distance formula is x2 minus x1 whole square plus y2 minus y1 whole square and then square root of that. So I am a point and there are 2 points which are equidistant from me. So I have to apply the concept of distance formula. So I have applied PA equal to PB. Then the distance of P and A can be calculated using distance formula x2 minus x1, y2 minus y1, or I can write this formula also, x1 minus x2 whole square plus y1 minus y2 whole square. Both the formula are the same. We can use any of them because if we do x2 minus x1 whole square or x1 minus x2 whole square, the value remain same. So I have applied here x minus 2 whole square plus 0. This is also minus, so minus minus becomes plus whole square. Square root is equal to x plus 2 because it is already minus whole square. 0 minus 9 whole square, square root. Now to remove the square root, I am squaring both sides. So I get the square roots are removed. X minus 2 whole square, 5 whole square, x plus 2 whole square plus minus 9 whole square. Opening the formula, a minus b whole square. This is a plus b whole square. I get a square plus b square minus 2ab. Square of 5 is 25. This is x square plus 4 plus 4x. Square of this is 81. Taking all the value to the left side and putting RHS equal to 0 and then simplifying it, I get the value x equal to minus 7. So the required point on the x-axis is minus 7, 0. Now if the question is asking find a point on the y-axis, if the question will ask find the point on the x-axis, the point that will take is 0, y. So this is the only variation we need to do. If the point is on the x-axis, the value is x, 0. If the point is on the y-axis, the point is y, 0, y. So by this, if the word is equidistant is given in the question, we have to apply this concept PA is equal to PB and then apply the distance formula. Now we'll see one more question based on the similar concept, but in that we need to make a equation. Now we'll see one more problems based on the equidistant concept. The question is, find a relation between x and y if the point 3, 6 and minus 3, 4 is equidistant from x, y. So we have a point P whose coordinate is x, y, and there are two other points A and B whose coordinates are 3, 6 and minus 3, 4. Now they are at equidistant. Equidistant means they are at equal distance. So the concept of distance formula should apply here. The formula is under root of x2 minus x1 whole square plus y2 minus y1 whole square, or under root of x1 minus x2 whole square plus y1 minus y2 whole square. Both are correct. We can use either of them. Now, since they are equal, we have written PA equal to PB, the condition of equidistant. Now apply the formula, distance formula, x minus 3 whole square, y minus 6 whole square plus under square root. This is also x already minus, so we have x plus 3 whole square, y minus 4 whole square root. Now to remove this square root, I have done here squaring both sides. So after doing the squaring both sides, the square root removes. So we have x minus 3 whole square plus y minus 6 whole square is equal to x plus 3 whole square plus y minus 4 whole square. So here we have two identities, a minus b whole square and a plus b whole square. The formula is a square plus b square minus 2ab, a square plus b square plus 2ab. So I have just opened the bracket, a square plus b square minus 2ab, a square plus b square minus 2ab, a square plus b square plus 2ab, since we have a plus, a square plus b square minus 2ab. Taking all the value to the left side and putting RHS equal to 0, eliminating the like terms which are in plus and minus, then I have minus 12x minus 4y plus 20 equal to 0. Taking this to the right side, minus 20, simplifying it, and I get 3x plus y equal to 5. Whenever there is a word in the question relation, it means we have to find equation related to x and y variable. So I got 3x plus y equal to 5. So I hope you understand the concept of equidistant. The concept of equidistant say that they are at equal distance, and in order to solve the problem by distance, we need to apply the formula of distance formula. So now I am going to tell you some more problems based on distance formula. We'll see one more problem based on the distance formula. Show that the points A, B and C are the vertices of right triangle. These 3 points are the vertex of the right triangle. For a right triangle, the Pythagoras theorem should verify, that is, the sum of the square of any two sides must be equal to the square of the third side. So what I have done, I have 3 points. I have calculated the distance AB, 5 minus 2, 2 minus of this already minus, so we have plus. Calculating, I get root 25, which is 5 units. Then I have calculated BC, 2 minus already, so we have 2 plus 2, minus 2 minus 1. So this is 4 square, this is minus 3 square. Calculating, again I got 5 units. And at last I have calculated CA, which is 5 plus 2 and then 2 minus 1. Calculating, I get root 50. Now if I do the square of this AB and this BC and sum it up, I will get the square of CA. So the condition of Pythagoras is verified. Sum of the square of two sides is equal to the square of the third side. So in this case, these are the vertices of the right triangle. Similarly, by applying the distance formula, I can prove, or you can also prove, that the vertices are the vertices of isosceles triangle. They are the vertices of equilateral. For isosceles, any two sides are equal. For equilateral, all the 3 distances are equal. And so on for the quadrilaterals also. All these type of problems are given in the exercise 7.1. So you try solving it. If you find any doubt in any of the question, you can message me or you can call me also. In the next class, we'll start the section formula topic based on the coordinate geometry. If you have any doubt, that also we can discuss in our next class. Till then, you try solving some questions and be safe and best of luck for the questions.